Ohio Minasama. Let's just start the current to electricity lecture one summary. So first of all, we'll talk about what is electricity, and electricity is defined as charge per unit time, but it is also defined as charge flown through mm, cross section. But we are more interested in it in terms of time. So I equals to Q by T. If it is instantaneous current, we'll say dq by dt, and if it is average current, we'll say that it is delta q by delta t. So one of the graphs where we can use from it is we can find total charge, which is as q as I into t. So we can use IT graph, I versus t graph, I in y axis, t in x axis. We can find out total charge, which is area under curve. So now, if it is uniform, we can use standard methods. But if it is non-uniform and we had any random shape, we would have to apply integration. So it would be dq integrated would be I as a function of t into d. Now we have charge density. It is current density. So current density is represented by J dash. It is a vector quantity and it is in the direction of the current, which is n cap. N cap is the unit vector in the direction of electricity. So I by A. And I hadn't talked about the direction of current. It is from higher potential to lower potential, which is plus 2 minus, and in terms of electrons, it is opposite to the flow of electrons, and electrons flow from negative terminal to positive terminal. So now A by A n cap. Uh, Thus, from this, if we take its a scalar version, you can say I equals to J dash dot A. Now, if we take its dot product, it is J A cos theta. I equals to J A cos theta. And that's our another formula. J equals to I by A n cap. And then we have I equals to J A cos theta. Now we will take one example. So now we will take an example which is about total charge flown through uh, cylindrical wire. It is not hollow, it is solid. In the solid one, we'll take a cross section. It is dr, suppose, and from center to it, it is r. But we are given that its total radius is capital R. So dA, this cross sections area dA equals to pi r dr, pi r dr. Now we'll use this in the formula JA cos theta. We are given J equals to J naught R by R. This was given. We'll use that J naught R by R. And as A is here, we'll write it would be dA. This would be dI. We are integrating this one. This would be pi R dr cos theta. And here, as charge is in the direction of the current, we'll say cos theta equals to 1. So now we'll bring all the constant terms, which is J naught R by outside, J naught R by R is outside, and also J naught pi is outside, R square dr. You can write R cube, J naught pi. This is from 0 to R. So this would be R cube, capital R cube by R by 3. This would be R square. So answer is J naught by R square by 3 by 3. this is our total current. Now, next up we have conductors. Conductors properties given and all, which we already know. Metals have large number of free electrons, and upon this large number of free electrons, we base a physical quantity which is number of free electron density. Yes, number of free electron density denoted by N. It is number of free electrons per unit volume, and that's it. We have no other formula for this. Let's write it here. Number of free electrons per unit volume. But it gets funnier if we use it in an example, and then we'll derive another expression for current using this and electric current density. That would be amazing. So we are given a metal with its atomic number 100 and only two free electrons per atom is released, and density is given as 10,000 or 10 to the power 3 kg per meter cube. So now we have to find number of free electron density from this. So we have number of free electrons. We can find it by getting, first of all, number of free electron density is equals to number of free electrons. So first of all, we have to get that, and then we'll write something from that. So first of all, we know that mass here is 100 grams per mole. So now m by m, we get here capital M equals to 100 grams or 0.1 kg. M by m here will be given mass, which we are not given here. So we'll just assume it to be small m. It would be m by, oh, we're not doing that. Number of moles would be, moles is given mass by total mass, and then number of atoms would be small m by capital M into Na, and then number of free electrons, which is two free electrons per atom. So number of free electrons would be 2 into small m by m into Na, and then we'll just, what would we do? Now we have gotten our number of free electrons to m by m into V and Na. We know that m by V is rho, so 2Na by m into rho. Now we just substitute all the values. 2 into 6.023 into 10 power 23 divided by mass here is 0.1 into rho is 10 power 3. Zeros, 10 se 10 cut out. This would go there. 6 to 12. It is a 4, 6 into 10 power 21. That's our answer. Next, number of free electrons determines how much good conductor is. Number of, then we have for non-uniform, I have already told this, we'd have to integrate that time. Uh, then we have another example based on uh, using this and this. Sorry, not that. Number of free electron density and current density, we can make a new formula for our current. So if we take randomly some electrons from here and there in a conductor, we get them in an imaginary cylinder, we'd have, and all these have random velocity v, then v in some time dt, they travel v into dt, and mm, if we consider uh, the cross-sectional area to be A, then we have volume as uh, A v dt, that is J is equals to, we know that it is the, the total charge in this would be total electron charge equals to Q times kV dt. So now if we put this, we have I is equals to Q by T, total charge by T, that is Q into AV dt by T dt. dt dt cancels, so I equals to QAV. Now if we use this and put this in electron charge density, sorry, this is current density, we'd get, we have I into A cos theta, not I into A, it is I by A. So we have QAV divided by A. Oh shit, think we forgot about something. That is, we have total number of electrons, that is total charge upon the T. And we forgot about N. We'd have to multiply N, 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 because N is number of free electron density. So to get number of free electrons, we'd have to divide the total volume. Oh man. Now we just cut A with A. So J equals to N Q V and I equals to N A Q V. Just write it. N equals to I equals to N A Q V and J equals to N Q V, and J would be in the direction of velocity of the electrons. That's it. We're done.